Got to be a constant. It's going to change when you change the labels of the variables. So we need to keep that the same for all the variables. What would that be? Well, pressure is P. As you know, the label for that is going to be in atmospheres. Or ATM. Okay, V is volume. And that's going to be measured in liters. So if you get something else, you have to change it to liters. If I give you like PSIs or kilopascals or inches of mercury or whatever, they all have to be changed in atmospheres when you plug it into this equation. And of course we said it's the number of moles. So that's just plain moles, nothing fancy about that. And T, like any other gas law that we deal with, or any law really, for the most part, has to be, this is temperature, and this has to be expressed in Kelvin. Not degrees Kelvin, just Kelvin. You put all that together, and your value for R becomes 0.0821. Now again, this is going to be a constant, which means that the labels make 0 sense. The farther up in the mathematics and science you go, the more you realize that the labels is a head scratcher because they seem to have no meaning as far as physical measurements are concerned. But they're actually tying together all the labels into the expression. And so I do want you to write this down every time you use it in a formula. That is liter atmospheres over mole Kelvin. Liter atmosphere over mole Kelvin. It's just a tying of all the variables together and we're refining. Why? Well, if you take a look at this, if you have N here, or R here rather, you get R by itself, you divide both sides by MT, so pressure, volume, moles, temperature. So atmosphere times liters, which I call liter times atmosphere, and on the bottom, moles Kelvin. Moles Kelvin. So that's where we get that from. That's why it's like that. So all calculations involving ideal gas law has to have that involved for R. So let's take this example here. We have 15 grams of neon at STP, and we want to know what volume it's going to have. Okay? So, take, if we write down all the variables P, V, N, and T, we know R is 0.0821 liter atmospheres over mole Kelvin. Pressure has to be in atmospheres. Well, STP, the standard pressure is 1 atmosphere. So we just write 1 atmosphere. Like I said, if I give you a quantity in PSIs, you got to change the atmosphere. If I give you a pressure in terms of kilopascals, you got to change it to atmospheres. The volume is what we're trying to find out, so that is our unknown. The N is the number of moles, all right? So we're given grams instead, so we have to take 15.0 grams times, and now we got to convert that to moles, 1 mole over. So you go to your periodic chart, and you find neon is 20.2 grams, rounded off to 3 sig figs. So you take 15.0 and divide by 20.2, and you get 0.743 moles. Temperature here, Standard temperature is 0 degrees Celsius. And we have to add 273 to that, to change that to Kelvin, and that will give us 273 Kelvin. So there's our information right there, all laid out in front of us. All right, so now we go to the formula, PV equals nRT. Now I love math, I do. And I like to use math in a way that makes my life a little bit easier. You don't have to do it this way, you can leave it in that form. But since I know I'm solving for volume, I'm going to divide both sides by pressure to get the volume by itself. So V equals nRT over P. Like I said, you don't have to do that. You can leave it in this form and just use your algebra skills using numbers instead of letters. And that's fine with me. But now we're going to go ahead and plug in all the numbers. We said N is 0.743 moles. R, 0.0821 liter atmospheres over mole Kelvin. And then the temperature is 273 K. All divided by the pressure, which is 1 atmosphere. Now this is another reason why I like putting variables in the setup, is because if you kind of like get lost in all the noise of letters and everything, and you're not sure what the label's going to be, even though it says V, you can use your cancellation process to get rid of the atmospheres, denominator, numerator, moles, denominator, numerator, Kelvin, denominator, numerator, and that leaves us liters. So which is what volume is supposed to be measured in, as we know. And so we just go ahead and punch those numbers in. 0.743 times 0.0821 times 273 divided by 1, and we get well, it would probably help if I actually put the right number in. And so somehow I screwed that. I don't know how I did that, but I did. I get 16.7, and the label, like I said, is liters. And that's all there is to it. So it's just a matter of plug and play. Make sure that you're plugging in the right numbers with the right labels. Your practice problems. You have 5 practice problems. Plug and play stuff. Have fun!